circle geometry 1. Under it, we have 5 theorems. So we are going to start with the first theorem. The first theorem says a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. That is, if you have a circle like the one given here, a line AB is the chord. Now, if I draw a line from O, which is the center, to the chord at M, that line from the center will perform 2 functions. The first function is that it will divide the chord into 2 equal halves. That is, AM is equal to BM. And not only that, it will also form right angle with the chord. Then, you can see the line OB. OB here is from the center to the circumference. And a line drawn from the center to the circumference is radius. So OB is radius, OA is also radius. Now, how do we solve question from this? To solve question using theorem 1, we use Pythagoras theorem. And the radius, being the hypotenuse, is equal to the sum of the square of OM, which is the line from the center to the chord, and MB, which is half of the chord. So, we can say that using Pythagoras theorem, R square is equal to OM square plus MB square. But if I'm looking for the length of the chord AB, I will also use Pythagoras theorem, but you can also use this formula, AB equal to 2 open brackets square root of R square minus OM square, then close the bracket. Then when are we going to solve question using this formula? 1, if you are giving the radius and the length of the chord, or you are giving the radius and the distance of the chord from the center, or you are giving the distance of the chord from the center and the chord, the length of the chord. Then we can move to theorem 2. In theorem 2, the angle at the center of a circle is twice the angle at any part of the circumference. That is, if you look at this figure here, this circle, you will see that we are having center O here. Then we have a point A and point B. The line that formed the angle at the circumference here at C came from A and B. So a line came from A and B to the circumference to form the angle at C. Another line came from A. So this OA is radius, then OB is radius. So the 2 radii form this angle at the center. What this theorem 2 is saying is that the angle at the circumference here, we can use to calculate the angle at the center. So the angle at the center is twice the angle at the circumference. So if this angle is 60 degrees, this one will also be 60 times 2, which will give me 120. If this one is 40 degrees, this will be 40 times 2, which will be 80. Then, the major problem is that we can't use this one to get this because they are enclosed in the same quadrilateral. The only thing is that if you are given this one, we can use this to get the reflex. So if this one is y, the angle at the center will be 2y. So we are still working with theorem 2. The angle at the center is twice the angle at the circumference. But looking at the figure, angle AOB is equal to 2x, the angle at the center twice the angle at the circumference. Then the reflex of it, which is reflex AOB, is equal to 2y because the angle at the center. So we can say that at the center we can have two angles, the main angle and the reflex. And the sum of the main angle and the reflex, as you can see here, is equal to 360 because both of them meet at a point. Sum of angle at a point is 360. If you factorize 2 out, we are going to have 2 into x plus y equal to 360. By the time you divide both sides by 2, you have x plus y equal to 180 degrees. That's for theorem 2. Then theorem 3. This theorem says that angles in the same segment are equal. Angles in the same segment are equal. The function of a chord is to divide a circle into two segments. The major segment is the bigger segment, while the smaller segment is called the minor segment. Now, if I draw a line from A to the circumference and from B to the circumference, they will meet at C here. So if they meet at C, then they will form an angle here. Let's call the angle X. Then if I draw another line from A and B to the circumference, meeting at D, I will have another angle here, which I will call Y. So if you look at the diagram, you see that angle X and angle Y, they are the lines that form them are from the same source, point A and point B. Not only that, the angles are facing the same direction. So from here, we can say that they are angled in the same segment, which means that they are equal. Then, how do you recognize angle in the same segment? Number one, they must be from the same source. From the same source. Then number two, they must face the same direction. If you look at the pattern, you will see that they are from the same source and they are facing the same direction. Then theorem 4. Theorem 4 says that the angle formed by a diameter with the circumference of a circle is 90 degrees. Although in some textbooks, they can write it as the angle in a semicircle is right angle, because the function of a diameter is to divide a circle into two equal halves, and half of a circle is called a semicircle. So this is a semicircle, and the upper one also is a semicircle. So if you look at the diameter, at the end of the diameter we have point A and B. Now if you draw a line from A to the circumference and from B to the circumference, what this theorem is saying is that the angle that will be formed at the circumference here at point C will be equal to 90 degrees. That's why I say angle ACB is 90 degrees. Then theorem 5, which is the last theorem. Opposite angles of a cyclic quadrilateral are supplementary. A cyclic quadrilateral is a quadrilateral that has the four vertices, that is the four corners, touching the circle. As you can see here, the four corners A, B, C, D are touching the circle. So the opposite angle are the angle facing each other. This angle A and angle C, they are opposite angle of a cyclic quadrilateral. So they are supplementary, meaning that the sum of A and B will be equal to 180 degrees. Then angle B and D, they are facing each other. So they are opposite angle of a cyclic quadrilateral. So their sum will be equal to 180 degrees. Thank you.